Hello, grade 12. In today's lesson, we're going to be looking at vertical projectile motion, and we are doing basic grade 12 VPM. Without any further ado, let's get right down to the lesson. So now we are given question 3. It says a man throws ball A downwards. So downwards, that's our direction of motion. Then with a speed of 2 meters per second, that's our V initial, from the edge of a window, 45 meters above a dam of water. 1 second later, he throws a second ball B, downwards, and observes that both balls strike the surface of the water in the dam at the same time, right? So these balls were not thrown at the same time. Ball B was thrown 1 second after ball A, but then he observes that they hit the dam at the same time, right? So we have 3.1. It says calculate the speed with which ball A hits the surface of the water. Now with this, you're gonna realize that what we are doing with VPM is we are taking the equations of motion back from grade 10, right? But then the only difference now is that the motion is now vertical. Remember, in grade 10 we were looking at the motion horizontal. Hence, even our distance had delta x, right, or our displacement had delta x. Now with this one, we're gonna be there's gonna be a slight change in terms that now for the displacement or the distance, we're gonna be using delta y. Why? Because our objects will be moving vertically, right? So still the same thing. When you are faced with this question, the first thing that you have to do, since you can see that you have 4 formulas, one trick about this will be having to choose the correct formula. Now, in order to make sure that you choose the correct formula, what will help you is to collect the data, right? So remember, now we want to calculate the speed in which ball A hits the surface of the water. So now we're going to look at all the information that we've been given on ball A. We are given VI, which it's 2 meters per second, right? And then we are looking for VF. We don't have that one, right? But then we are told that from that edge of the window to the surface of the water on the dam, that's 45 meters, right? So we do have the displacement. And then what else? Again, we have acceleration. Remember, we highlighted the downward to show you that it is the direction of motion. Now, if you choose downward as the direction of motion, we know that our gravitational acceleration becomes positive 9.8 meters per second square. Now, the advice with this one, this A, 9.8, is that when you read the statement and it says downward, it's best to go with downward as positive. When you read the statement and it gives you the direction of motion as upward, say maybe the question says a projectile has been thrown upward, then it's best also to take your upward as positive, right? So you always take the direction of motion that is indicated on the statement as the positive direction. Then that will give you your 9.8. If downward is positive, it's positive 9.8. If upward is positive, then it's negative 9.8, right? Now that you have all this information on ball A, it's time to choose the correct formula. How do you choose the correct formula? You check which formula between the 4 corresponds to the data that you have, right? So now let's see, we have VI, we have VF, we have delta Y, and then we have A. Which one corresponds to that? If we look at the formula, the first formula, we can see that this one has changed in T. It has all that, but then the problem is it has changed in T, and we are not looking for change in T. We are also not given anything on change in T. The only thing that has been spoken on time is that ball B has been thrown 1 second after ball A. Remember, that doesn't mean that ball A traveled for 1 second. It only means that 1 second after ball A was thrown, then ball B was thrown after, right? But then at that time, ball A had not reached the surface of the water. Now, when we look at these other formulas again, we can see they all have change in T, which is a problem. But let's look at this one. This one seems to be perfect. We are looking for VF. squared. We are looking for VF. Here we have VF squared, so check. We do have that quantity. We do have VI, and they have VI here. We do have acceleration, and then we do have delta Y, right? Now that means the correct formula to use is that one. So let's go now. That means remember, with a 3-mark question, it's only a matter of choosing the correct formula and substituting into the correct formula and get that mark. So 1. Then our VF squared, we don't have that, but our VI is 2, and then square that, then 2. A is 9.8, and then delta Y is 45. Now if you punch all that in your calculator, it gives you 886. Then at this point, you will remember we are not looking for V squared but for VF, so we can square both sides. Now our VF is equal to 29.77 meters per second, right? So that's the speed, right? That's the speed with which it hits the surface of the water. Nice. Now 3.1.2 says calculate the time it takes for ball B to hit the surface of the water. Now if we look at ball B, we can see that the only information that we have on ball B is that it will also travel a distance of 45 meters, since it has been thrown at the same height as ball A, and then it is being thrown by the same man, which is in the same, which we assume he's in the same position when throwing all these balls. Then so ball B moves a distance of 45 meters, but then that's the only thing that we have on that, and the fact that it is thrown 1 second later, right? Now that means what would be the approach here? It would be best for us to calculate the time it takes for the whole journey of A. Then after getting that time, we say, oh, ball B moved 1 second faster than ball A. That means whatever the time or the duration of the journey of ball A, it will be -1 from that to ball B. Now let's check the information on A. Again, we're going to tackle from A. Then we have VI, it's 2 meters per second, and then we have VF is equals to 29.77 meters per second, and we have our A still 9.8. Remember, when you choose downward as positive, when you choose your direction of motion, you have to continue with it throughout the question. Even if the object changes direction, you have to continue with that throughout. Then changing T, we don't know it, we are looking for it. Now, having all this information, which formula best describes that one, or which formula can fit to this or to all this data that we have? We can see it's formula number 1, right? So even these other ones, they can fit, because remember we still have delta Y, and delta Y is equals to 45. So even these other ones would be ideal to use, but then right now we are looking for the simplest one. So the simplest one has to be VF is equals to VI plus A, changing T. So now let's write that one. It's VF, VI plus A, and then changing T. What is it that we have for the final velocity? Remember, we calculated in the previous question, it's 29.77. Then our VI is 2. Then our acceleration is 9.8, and then changing T. Now at this point, we can transpose this 2 to that other side. Then we 29.77 is going to be -2. So it's 27.77 is equals to 9.8, changing T. Then we can divide both sides by 9.8, divides both sides by 9.8. Our changing T now will be 2.83 seconds. But then remember, now in context with the question, this is the time that it takes ball A to move all the way from the edge of the window to the surface of the dam. But now remember, ball B was thrown 1 second after, right? So that means ball B traveled 1 second faster than ball A. So we need to, for ball B, change in time for ball B, it's going to be 2.83 minus 1, which will now give us 1.83 seconds. So the answer for your ball B is 1.83 seconds, right? So that's the time it took. Now 3.1.3 says now calculate the initial velocity of ball B, and that for 5 marks, right? So now we are looking for the initial velocity of ball B, right? Now again, you don't panic. Let's collect the data. Remember, we calculated change in t and then we said it's 1.83 seconds, right? We are looking for VI, so write a question mark on that. Our acceleration, remember, downward is positive, so it's positive 9.8 meters per second. And then what else do we have? We know that ball B is also traveling a distance of 45 meters because it was thrown at the same height as ball A, right? Now, having all that, which formula fits perfectly to all the data that we have, right? So which one has VI, change in T, change in Y, and A? We can see that it is this one, right? So change in Y, check. VI, we are looking for a check. Change in T, check. And then we have acceleration, check. So now that you have that, you write your formula. Then this is your formula goes change in Y is equals to VI, change in T, plus half acceleration change in T squared, right? Now, what is your change in Y? That's 45, right? And then what's your VI? We don't know that. We are looking for VI. And then what is our change in T? It's 1.83, right? Remember, we are looking at ball B, then half, and then our A is 9.8 positive. And again, here we have 1.83, and then square that. Now, that means we'll have 45 is equals to 1.83 VI. Now, if you punch all that in your calculator, what is it that you have? We have plus 16.41. At this point, what can we do? We can just transpose the 16.41 to the other side. So we have 45 minus 16.41 is equals to 1.83 VI, right? Now, finding the solution to that one. So 45 minus that. So we have 45 minus that. It's 28.59. 59 is equals to 1.83, and then we have V, right? Then divided by 1.83, divide both sides by 1.83. Now our VI becomes 15.62 meters per second. So you see why, even though ball B was thrown 1 second later, it still arrived at the same time with ball A, because ball B was thrown at a much greater velocity. So it was able to catch up with ball A, right? Then 3.2, we have on the same set of axes, sketch a velocity versus time graph for the motion of balls A and B. Clearly indicate the following on your graph: initial velocities of both balls A and B, the time of release of ball B, the time taken by both balls to hit the surface of the water. So you need to check all those points because those are the ones that will give you marks, right? So now, drawing a velocity versus time, we know that we have something like this. Then let's see now the initial velocities. So the initial velocities here, remember with the velocity versus time graph, this 0 point here, it does not indicate the ground, but it indicates the maximum height, right? So because this thing is being thrown downward, we know that it won't reach the maximum height, because remember, it is thrown from that height, maximum height. So the velocity here for ball A is 2, so we can indicate that one. and then go but then remember this is time in seconds and this is velocity in meters per second, right? So you can just indicate that. And then ball B was thrown 1 second later, so we can just indicate that 1 second there. And then now it goes ta 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 ta, so it was thrown 1 second later. Let me erase that one. So there we have it. And then so 1 second later we had ball B being thrown. So this is B, let's indicate this is B, and then the first one is A, right? And then what is the time that they both took to reach the ground? We can just indicate here, ta ta ta, and then ta ta ta. So we have it like that. Then the time that they both took is 2.83, right? But remember, when you check the difference, remember B is starting 1 second later, so that means it had a chain of 2.83 minus 1, which is 1.83. But then ball B started all the way from the zero, from T0, then all the way to T 2.83. So ball A, it had a journey of 2.83 seconds. Its whole journey took 2.83 seconds. And ball B, its whole journey starting from T1 to T 2.83 took 1.83 seconds. So that's how you indicate that one, right? So here obviously you'd have it going all the way to that one. So yeah, awesome. So that's it for 5 marks. You have that for 5 marks for indicating all those. We need to also indicate, they said we need to indicate the velocity of ball B. So we had to remember it's 15.62. Yes, 15.62. And that's how you have it. We have the velocities. Let's check if everything is in order. Initial velocities of both balls A and B. Those are our initial velocities, 2 and 15.63. And then we said the time of release of ball B. We do have the time of release of ball B, right? So that's a mark, that's a mark, that's a mark. And then we have the time taken by both balls to hit the surface of the water. It's 2.83. Then that's 4 marks. Maybe they would mark the shape according to the criteria. Then you have your 5 marks like that. Awesome. Now let's look at question 4. It says a ball is dropped. So there's a keyword there. A ball is dropped, right? A ball is dropped from the top of a building 20 meter high. Ignore the effects of air friction. Now 4.1 says define the term free fall. What is free fall? Let's run quickly to that. We say free fall is the motion of an object upon which the only force acting is the force of gravity. So you have your 2 marks in the bag like that. Then 4.2, calculate the speed at which the ball hits the ground. The speed at which the ball hits the ground. Now let's check. What is the data that we have on this one? We are given that VI. So we are not exactly given, it's the keyword. We know that since they gave us dropped, we know that VI is equals to 0 meters per second, right? Because if something is dropped, that means it is not given any initial velocity. Then VF, and we are looking for VF. Then our A, remember now it is dropped, we take downward as positive. When it is dropped, it goes down. So our A is positive 9.8 meters per second square, right? And then we are also given the change in Y, which is 20 meters, right? Now having all that VI, VF, A, change in Y, what formula can we use for that one? We can see that the formula that agrees with that one is VF squared is equals to VI squared plus 2A change in Y. So let's use that one. Now we have VF squared is equals to vi squared plus 2a change in y, right? Then the vf squared, that's what we are looking for. Vi is 0 because it was dropped, and then we have 2. Our a is 9.8, and our change in y is 20, right? Now you punch all that in your calculator. It gives you vf squared is equals to 392. Then at this point you square both sides, then vf is in the same direction as vi, so it comes out as a positive. It's 19.80 meters per second, right? And that's the velocity or speed in which it hits the ground. Then 4.2.2, this says calculate the time it takes the ball to reach the ground. Calculate the time it takes the ball to reach the ground. Again, let's look at the data that we have. So to reach the ground, remember we already have vf, and then our vf is 19.80, but we do have vi is 0. Then what we have our acceleration is 9.8 meters per second square, and then we are looking for change in t. Again, let's look at the formula that will compensate for that one. So it's vf is equals to vi. So this one is perfect for that one because we have everything here. We have vf, we have vi, we have a, and we are looking for delta t. So we can use the first formula there. So you see how easy it becomes when you have collected your data. So it's just a matter of plug and play there. Then vf, it's 19.80. Then we have our vi. Our vi is 0. Then we have our acceleration is 9.8, and then we have delta t. So we are left with 19.80 is equals to 9.8 change in t, and then we can divide both sides by 9.8. Divide both sides by 9.8. Our delta t now is 19.80 divided by 9.8. That gives us 2.02 seconds. So that is the time it takes to hit the ground. Awesome. So for 3 marks, you have it in the bag. Then 4.3 says sketch a velocity time graph for the motion of the ball. No values required. So here they will only mark the shape, right? So they will mark the shape and also the labeling of your axis, because they only want the sketch with no values. So now we know when we take a downward as positive, our graphs look like this. Remember, this is starting all the way from 0. This is starting all the way from 0. So the velocity at this point is 0. So it has to start here, obviously. Then it goes, and then what is the velocity? Remember, we are not required to show that. We are not required to show any values. So you just label this is time, and this is velocity in meters per second. So this is what will happen. Remember, when you are throwing something down, the graph becomes an increasing straight line graph, because when you are throwing something down, its kinetic energy increases, right? So there's an increase in kinetic energy. So that's why you see the velocity is increasing. So when you throw something down, its velocity increases. As you can see, it was dropped from a velocity of 0, but then we can see the VF is 19.80. So that increase, or that increasing graph, is indicating that the velocity is increasing and its kinetic energy is increasing as it goes down. Okay, now let's look at question 2. It says ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as 0 reference. 2.1 says calculate the time taken by ball A to return to the ground. Now if we check what happened here, we can see that we have a parabola type question whereby we can see that this is a symmetry. So this ball started from the ground at 16 meters per second. It goes all the way to the maximum height and returns back to the same position. Now we know if a ball returns back to the same position, it will also have the same speed at that position. But then remember, when we indicate now the velocity, we say it's negative because now it's going in the opposite direction of motion. So remember, it was 16 meters upward, and we chose upward as positive because remember, ball A is projected vertically upwards. So now the direction of motion that we are told of automatically becomes our positive direction. Then 16 meters per second upward is positive. That means when it's going down 16 meters per second downward, it will be negative, right? Now to calculate the time taken by ball A to return to the ground, let's now collect our data. We have VI is equals to 16 meters per second positive, and then we have VF is equals to negative 16 meters per second. We have our acceleration, which if we choose upward as positive, we know our acceleration becomes negative 9.8 meters per second square. And what are we looking for? We are looking for delta t, the time, right? Now, having all that information or the data, let's see what formula can work for us. Then we have VF, VIA, and change in t. That means the first formula is perfect for that one. Now let's go and calculate. So that means we have VF is equals to VI plus A change in t, right? Now what is our VF? Remember, it's now negative 16 because it's going in the opposite direction. Our VI is 16, then we have plus A is negative 9.8, and then we have change in t. Now having to transpose that 16, it becomes negative 16 minus 16, that's negative 32, and then here we are left with negative 9.8 delta t. Now to find our delta t, let's divide both sides by negative 9.8, negative 9.8. Now our delta t is 3.27 seconds. Awesome. And that's how you would have your 4 marks in the back. Now 2.2 says sketch a velocity time graph for ball A, then show the following on the graph. So this is where we'll get our 3 marks, showing the initial velocity, showing the time taken to reach the highest point, and then also showing the time taken to return to the ground. Now let's draw our graph. You will remember that we said that our graph becomes a decreasing function if we take upward as positive. Why? Because when the object is thrown upward, it loses kinetic energy, right? So as it loses kinetic energy, it loses the velocity, right? Up until it comes to the maximum height where the velocity becomes 0. So let's indicate that in a graph. So this is the object. Remember, this doesn't mean that your object is being thrown like a meteor or a rocket like that. This means that the velocity of the object is decreasing as the object is going upward. So as the object is going upward, it's decreasing up until it reaches where the velocity is 0 at the maximum height. Remember, now this indicates that we are in the maximum height, right? So it starts at a velocity of 16 and then decreases all the way to 0 at the maximum height. Then when it reaches the maximum height, it now goes back down. So when it goes back down, can you see what is happening now? It is now increasing in the negative direction, because when it's now going down, the velocity needs to increase, right? So the kinetic energy increases when an object is going down. Now we indicate that. Now what is it that we need to indicate? The time it took for it to go back to the ground. So the total journey of the time was the total time of the journey was 3.27 seconds, right? Now if we say this is a parabola which is symmetrical, we know that the time it took to reach the maximum height is half the time for the whole journey, right? So that means in this case we need to calculate the midpoint here. So we have 0 plus 3.27 divided by 2. Now that gives us 1.63. So that's the time it took for it to reach the maximum height, right? So we show it like that. Now when they give you your marks, you have indicated the velocity, the initial velocity of the ball. You've indicated the time it takes to reach the maximum height, which is half the time of the whole journey. And then you've indicated the time for the whole chain, where it now hits the ground. It goes back to its initial position. So there you have it. Now it's only a matter of labeling here. This is time in seconds, and this is velocity in meters per second. And that's your velocity versus time graph. So yep. You have it like that, like this. So your velocity versus time graph will look like that. Then 1 second after ball A is projected upwards, a second ball is thrown vertically downwards at a velocity of 9 meters per second from a balcony 30 meters above the ground. Refer to the diagram below. Now 2.3 says calculate how high. So how high, what are they looking for? That means they are looking for delta y, right? Then how high above the ground ball A will be at the instant the two balls pass each other. Now let's start to collect data on each ball here. So if we indicate ball A, what is it that we have on ball A? We are given the VI, which is 16 meters per second. We do have the acceleration is negative 9.8 meters per second. Remember, because we chose upward as positive. But then the delta y is just delta y. We don't know what is the height at the instant these two balls meet, right? And then we don't know at what time do they meet. So having all that, we can see this is a simultaneous type question because we have two unknowns. Then let's go to ball B. For ball B, we are given VI, but remember, ball B is moving downward, which is against the motion that we chose as positive, right? So that means it's negative 9.8 meters per second. Our acceleration, however, does not change because this depends on what we chose, what side we chose as positive. So we chose upward as positive. That means our acceleration will forever be negative 9.8 meters per second, right? So remember this one, the acceleration is affected by which side you choose as positive. If you choose downward as positive, then A is positive 9.8 meters per second square. If however you choose upward as positive, then our A is negative 9.8 meters per second square. Now, do we have our delta y? We do not. But then since we know this one is moving in the opposite direction of motion, that means our delta y will be 30 will be delta y. Remember, it needs to be negative since it's going opposite. So it's delta y minus 30, right? So we are saying whatever delta y we're going to find in ball A, we subtract 30 from it so that we find the delta y of B, right? So why we say delta y minus 30, remember now it's going in the opposite direction. Therefore, even its delta y needs to be negative. So if we subtract 30, that's how we're going to have the negative. Then our delta t, there's something that they said on the statement. They said 1 second after ball A is projected upwards, a second ball is thrown vertically downward. So we can see that the change in time for ball B is whatever delta t of A minus 1, right? The same way as the delta y is whatever delta y of A minus 30. So that's it. Now, having to calculate that one, so now we have all the information. Let's indicate now. Let's start by calculating for ball A. So we want to create an equation for ball A and create an equation for ball B. But first, before we go to that, let's see what formula can we use having all the data that we have here. Now we can see that we are looking for a formula without VF because we are not told of any VF here. So if we check all this, they have VF, not this one. If we check this, they all have VF, they all have VF, but this one is perfect because we have delta Y, we have VI, and delta T, right? So no VF, and then we don't have our VF in the data, so that one is perfect. Now let's go ball A. That means we use the formula delta Y is equals to VA changing T plus half A changing T squared, right? Now what is our delta Y? It's just delta Y, we don't know. Then VI is 16, and then we have our delta T plus half, but here we have negative 9.8, and then we have our delta T square. Now if we calculate that one, it's 16 delta T minus 4.9 delta T square, right? And this one, let's say it's equation 1. So we have created an equation in terms of delta Y. Remember, we are looking for delta Y because the question said how high, right? So in that case, we make delta Y the subject of the formula. Then let's check now for ball B. For ball B, what is it that we have? We have delta Y is equals to VA delta T. Same formula again, half G changing T square. But remember, our delta Y is now delta Y minus 30. So whatever delta Y of A minus 30 is equal to the VI is now negative 9, remember, opposite direction, and our delta T is whatever delta T of A minus 1, right? Then plus half, so let me put A here. Remember, it can be A or G. Then our acceleration is negative 9.8, and then delta T, remember now we have that and then it's squared, right? Our delta T is delta T of A minus 1, then now it's squared. Now that means we have delta Y of A. We can just transpose the 30 now. Then here, okay, let's not transpose it yet. So we have minus 30 is equals to, this one gives us negative 9 delta TA plus 9. Then we have negative 4.9. If you do that, it gives us delta T square minus 2 delta T plus 1. So that becomes a trinomial, right? If you do your maths. Then our delta YA is now, we can say it's negative 4.9 delta T square minus 9 delta T. Then this one times that one becomes positive plus 9.8 delta T. Right, so this negative 9 delta T is here, and then when we take this one and multiply it with that one, it becomes positive 9.8 delta T. Then we have negative 4.9 times positive 1, it becomes negative 4.9, and then plus this 9 here, and then also plus this 30 that we transposed. Right, so now with this side we are left with delta Y. Now do all that. If you punch that in your calculator, it now becomes delta Y is equals to negative 4.9 delta T squared. Then if you say the like terms here, negative 9 delta T plus 9.8 delta T, that gives you plus 0.8 delta T. Again, if you say negative 4.9 plus 9 plus 30, now the solution that you have is, the solution that you now have is 34 plus 34.1, right? So we can just go ahead and name this equation 2, right? Now that we have equation 1 and equation 2 and they are all expressed in the subject of the formula delta Y, we can say let's now equate equation 1 and equation 2. Now for equation 1, what is it that we have? we have 16 delta t minus 4,8 delta t squared. Then for this one, 4.9 delta t squared plus 0,8 delta t plus 34.1, right? Now we can see that we have like terms here which will cancel out. So if you transpose that one, it will cancel out with this one. Now we are left with 16 delta t transpose this one minus 0,8 delta t is equals to 34.1, right? Now you punch that in your calculator. 16 delta t minus 0.8 delta t, that gives us 15.2 delta t is equals to 34.1, and then divide both sides by 15.2. Our delta t now is 2.24 seconds. Remember, that's the time. Now that we have the time, we can go ahead and now calculate the delta y. So obviously, to calculate the delta y, it's best that you choose the simplest one, the simplest looking formula there, which is equation number 1. It was 16 delta t minus 4.9 delta t squared. Now at this point, we can see that it's just a matter of substituting the delta t and the 2.24 where there's delta t, then minus 4.4, and then where there's delta t we put 2.24, then square like that. Now if we do that in a calculator, now we have delta y is equal to 11.25 meters, right? So that's 11 delta y. So our delta y becomes 11.25 meters, and you are done. Voila. So that was your 6 marks. You can see it simultaneous, nothing difficult with that one. You just needed to collect your data correctly, and then you apply your simultaneous correctly, and you arrive to the answer with ease. So all the best. Continue practicing, and then next time we're gonna do more. Awesome.